Hello and welcome to this session on data types in C++. Today we will discuss in detail about data types in C++. Data types क्या होते हैं, कितने तरह के होते हैं, कितनी मेमोरी ऑक्यूपाई करते हैं, किस तरह के वेरिएबल के लिए किस तरह का डेटा टाइप हम यूज़ करते हैं, ये सारी चीज़ें आज हम जानेंगे आज के इस वीडियो में. Data types define the type of data that a variable can store. In C++, they are essential for declaring variables and performing operations on them. All variables use data type during declaration to restrict the type of data to be stored. Therefore, we can say that data types are used to tell the variables the type of data they can store. कोई वेरिएबल किस तरह का डेटा स्टोर कर सकता है, ये उसे कौन बताता है, उसका डेटा टाइप. फॉर एग्जाम्पल, a Boolean variable can have a Boolean data and an integer variable can hold integer data. Whenever a variable is defined in C++, the compiler allocates some memory for that variable based on the data type with which it is declared. What are variables? Variables are just storage locations reserved for storing values. Every data type requires a different amount of memory, and this amount of memory depends on the data type. In C++, data types are classified as, the first one is primary or the built-in data type. The second one is derived data type. These derived data types are derived from the built-in data types, and the third category is user defined data type. As we can see that in this figure, data types are classified into three major categories: fundamental, derived and user defined data types, and these categories are sub-classified into further subcategories. The fundamental data types is classified into integer, character, float and Boolean. Likewise, the derived data type is classified into function, array, pointers, reference, and the user defined data type is classified as structure, class, union, enum, etc. The first one is the primitive data type or the built-in data type. As the name suggests, these data types are built-in or predefined data types, and they can be used directly by the user to declare variables. Built-in data types available in C++ are: the first one is integer. As the name suggests, the keyword used for integer data types is int. These data types are used for storing integer values. Integers typically require 4 bytes of memory. For example, int a equals to 124. Here a is a variable of integer type and it can only hold an integer value. Second one is the character. As the name suggests, the character data type is used for storing characters. The keyword used for the character data type is char. Characters typically require 1 byte of memory space. Single quotes are used to enclose characters in C++. For example, char ch equals to, in single quotes, s. Here ch is a character data type variable and it requires 1 byte of memory. The third one, floating point. This type is used for storing single precision floating point values or decimal values. For example, if we need to store a percentage value or simple interest, we would require this type of data type. The keyword used for this is float. It has a size of 4 bytes. For example, float PER 81.26. Here PER is a floating point data type variable. The fourth one is Boolean. The keyword used for the Boolean data type is bool. Boolean data type is used for storing logical values. It can store either true or false. It requires 1 byte of memory space. For example, bool b1 equals to true, where bool is a Boolean data type variable. And the next one is void. As the name suggests, void means without value and empty. The void data type represents a valueless entity. Variables of the void type cannot be declared. It is used for functions which do not return any value. Now let us come to the second category of data type, which is the derived data type. These data types are derived from the primary or the built-in data types and are referred to as derived data types. These can be of 4 types, namely function, array, pointers, references. The first one is the function. What is a function? A function is a block of code or a program segment that is defined to accomplish a certain well-defined task. Typically, the purpose of a function is to prevent the user from repeatedly inputting the same lines of code for the same input. All of the lines of code are combined into a single function which may be called from anywhere. Main is a default function that is defined in every program of C++. The syntax of a function is function type followed by function name and in parentheses some parameters. The second one is array. An array is a data structure which is used to store multiple values of similar data type in a contiguous memory locations. The purpose of an array is to store a lot of data in a single variable name and in sequential order. Unlike other variables that we have discussed which were capable of storing a single value, but an array is capable of storing multiple values of similar data types. The syntax of array is data type followed by array name and in bracket array size. This data type is the same as that we have discussed in the built-in data type. For example, int arr5 equals to in parenthesis 49123. Here arr is an integer array of size 5 and these values inside the parenthesis are the elements of array. Let us look at this picture. Here we can see that 2, 4, 8, 12, 16 and 18 are the elements of this array and 0, 1, 2, 3, 4, 5 written below are the indexes of this array. The array index start from 0 and the index of the last element is n minus 1 where n is the size of the array. The next one is pointers. Pointers are symbolic representations of addresses. Pointers store the addresses of the variables having the same data type as that of the pointer. The size of the pointer is either 4 bytes or 8 bytes, no matter what the data type is. They enable programs to simulate call by reference as well as to create and manipulate dynamic data structures. The syntax of pointer is data type followed by an asterisk symbol and the variable name. A normal variable is used to store value, but a pointer variable is used to store address or reference of another variable. You can see in the picture the pointer ptr is storing the address of variable var. The address of variable var is 1004 and this address is stored in the pointer variable. Pointers are symbolic representation of addresses. We can have a pointer to any variable type. The next of the derived data type is reference. When a variable is declared as a reference, it becomes an alternative name for an existing variable. A variable can be declared as a reference by putting ampersand sign in the declaration. There are 3 ways to pass C++ arguments to a function: call by value, call by reference with a pointer argument, and the third one is call by reference with a reference argument. Example, int val equals to 1526, int ampersand ref equals to val. Here ref becomes the reference to integer val, and now any changes in one would be automatically reflected in the other as they both represent the same memory location. Now we come to the third category of data types, which is user defined data type. As the name suggests, these data types are defined by the user as per his need and requirement. The first one of which is class. Class in C++ is the building block that leads to object oriented programming. It is a user defined data type which holds its own data members and member functions. Remember, a class has data members and member functions which can be accessed and used by creating an instance of that class. And what is that instance? That instance is known as object. A C++ class is like a blueprint for an object. For example, consider the class of cars. There may be many cars with different names and brands, but all of them will share some common properties, like all of them will have 4 wheels, speed limit, mileage, etc. So here car is the class and wheels, speed limits and mileage are their properties. So in C++, a class is a group of similar objects. It is a template from which objects are created. It can have fields, methods, constructors, etc. We can think of a class as a sketch or a prototype of house. It contains all the details about the floors, doors, windows, etc. Based on these descriptions, we build the house, and the house is the object. In C++, object is a real world entity, for example, chair, pen, car, mobile, laptop, etc. In other words, object is an entity that has a state and a behavior. Object is a runtime entity. It is created at runtime. A class is defined in C++ using the keyword class followed by the name of the class. The body of the class is defined inside the curly brackets and terminated by a semicolon at the end. The second user defined data types that we are going to talk about is structure. We often come around situations where we need to store a group of data, whether of similar data types or non-similar data types. We have seen in arrays which are used to store set of data of similar data types at contiguous memory locations. But unlike arrays, structures in C++ are user defined data type which are used to store group of items of non-similar type. The term struct is followed by the structure name to define a structure. The structure's variables are all specified within the structure. Look at this syntax: struct followed by the struct name, and inside the curly brackets there are some data types. Here different data types such as an array of characters and integer data types are combined to make a new data type according to the user's need. The third one is union. While creating real world programs, developers are bound by the memory space of the systems they intend to run on. Memory is very crucial. The space complexity becomes essential as we never want to utilize more space than what is available at any given time to perform a function or process. Just like a structure, a union is also a user defined data type where we can store members of different data types in a single unit. But the difference is that the member variables in a union share the same memory location, unlike a structure that allocates memory separately for each member variable. The member of the union which occupies the largest memory decides the union size. It is defined in the same way as the structures are done. We need to use the word union in to define unions. For example, union sample, and inside curly brackets there are some variables. After defining the union, we can also create an instance of it the same way we create an object of the class or declare any other data type. The fourth one is enumeration. Enum in C++ is a data type that contains fixed set of constants. It can be used for days of the week, Sunday, Monday, Tuesday, and so on, or directions, north, south, east, and west. The C++ enum constants are static. C++ enums can be thought of as classes that have a fixed set of constants, a fixed set of some possible values. Enums or enumerations are generally used when we expect the variable to select one value from the possible set of values. To define an enum, keyword enum is used. For example, enum season, and inside curly brackets spring, summer, autumn, winter. Here the name of the enum is season, and spring, summer, and winter are values of type season. That's it. Let's have a quick refresher. What is a data type? Data types define the type of data that a variable can store. In C++, they are essential for declaring variables and performing operations on them. We can also say that data types are used to tell the variables what type of data they can store. Data types are broadly classified into three major categories: primary or the built-in, derived data type, and the user defined data type. These major categories of data types are further classified into subcategories. Integer, character, float and Boolean are fundamental data types, while function, array, pointers, references are derived data types, and structure, class, union, enum, etc. are user defined data types. That's all for today. Thank you for watching. Goodbye.